Dear students, today we will discuss next gas field detector, that is proportional counter. As the name suggests, a proportional counter operates in the proportional region of gas field detectors. You can see that design of this detector is same as that of ionization chamber that we have discussed in the previous lecture. The only difference is that it works at a higher voltage than ionization chamber. Gas filled in the chamber is usually an inert gas because the inert gas doesn't react chemically with the detector components. Amongst the inert gases, argon is usually preferred because of its higher specific ionization. Now let us discuss the working of the detector. The incoming particle produces primary electrons and positive ions of the inert gas through ionization. These ion electron pairs are accelerated towards their respective electrodes due to potential difference at electrodes. Due to this acceleration, they gain energy. If the energy of such primary electrons exceeds the value required to ionize the molecules can be ionized after collision with them. Let us see this process in little detail. As primary electron collides with argon molecule, it knocks out another electron from argon, which is called secondary electron. So electrons are doubled. The primary and secondary electron further gain energy through their acceleration towards anode. Hence, electrons will be doubled in the further ionization process. This multiplication process is known as Townsend's mechanism of the first kind. This way, each primary electron creates an avalanche independent of all other avalanches in the detector. Let us understand the gas multiplication factor more clearly. Suppose every primary electron produced by incident particle gives rise to a total of n secondary electrons by further collisions. Now it is not necessary that each secondary electron will cause ionization of gas. So let P be the probability that each secondary electron gives rise to a tertiary electron. Therefore, the number of tertiary electrons will be n into P. If each tertiary electron in turn produces electrons by further collisions with the same probability and so on, then gas multiplication factor m can be estimated by using the geometrical progression formula, which is given as m is equal to n divided by 1 minus n into P. Now let us see how much charge can be produced in the chamber through this whole process. The total charge produced in a proportional counter is given as Q is equal to m into delta E into E, where small e is the charge on one electron, and divided by W, where m is the multiplication factor, delta E is the energy of the incident particle deposited in the counter, and W is the average energy required for the production of one electron ion pair. Now, more the charge produced, larger is the size of the pulse. Therefore, size of the pulse in a proportional counter depends on multiplication factor m and energy of the incident particle. Multiplication factor further depends upon the voltage applied across electrodes. As higher the voltage, higher is the acceleration of electrons, which not only increases the probability of ionization but also the length of the ionization chain. Applications of proportional counter. As we have just seen that the pulse height depends upon the energy of the incident particle. Therefore, the pulse height is used to measure the energy of the particle. The number of pulses is a measure of the intensity of the radiation. So therefore, we can not only measure the energy of the particle in proportional counter, we can also measure the intensity of the radiation. In next lecture, we will discuss the Geiger-Müller counter, which you have already worked with in your practical classes.